Hi everyone. Today we are going to discuss about microservices architecture. What are microservices? To understand the microservices architecture clearly, let's start with a real-time scenario. As you wanted to start a business and you started a business with a kirana store and the various products you are trying to deal with like vegetable stationery, rice, cloths you are dealing, and the number of customers coming to your business, your store also has been increased. At that time, what you are doing, you are trying to make a bill for your customers. At the same time, you are trying to update your store items, and both the things are taken care by you only. And you are the alone a single person who is dealing with the updation of your items and also selling the items. Both you are dealing at a time. And this particular scenario, in this scenario, what happens? The number of customers coming to your business also increased because you are maintaining the quality. Then the number of customers coming to your store is increased. So due to this, you are updating your detail, your items at the same time you are billing. So that the queue, whatever happens in front of your store, also increases. See, in this particular scenario, the queue, whatever it is increased, you need to deal this queue effectively. Otherwise, what happens? So the customers will go to the other services. So this is the problem with this particular scenario. Then there is something um, in your mind. You don't want to lose your customers, so you are thinking how to solve this particular problem. There is a scenario occurred. So then eventually how you will solve this particular problem? Then okay, number of customers are coming, so my business is doing well, going well. Then I wanted to establish a system where all the people can be served and my business also will grow. Such a way you are thinking. Then what you will do, you will be dividing the different sections, and each section will be maintained by the different set of people, so that the number of customers coming to your store also will get served clear in time. The queue, whatever the queue you are trying to maintain, that will be cleared for on time to time basis. See how you divided your system. Let's try to understand this particular diagram. The first, you have the point of sale. Only that particular section is going to deal with the billings uh, of the items and serving the customers. And also you have the one more section called product service section, and they're going to update your products on regular basis. And then you have the inventory services, and who is keeping track of how the items are entering into the your store, and then how they are leaving, means how the sales are happening. All these things are maintained here. So such a way you divided business. Then you are relaxed with this situation. You are relaxed, like okay, so everyone is taken care by the one particular section, and then your business is moving smooth. So now, just I want to keep one thing in front of you. The first scenario, whatever we observe, the alone you are going to deal with the customers and updating the items. That is a monolithic architecture. Now you divided your business into the small sections, and each section is called a microservice, and each section is having their own responsibilities and their own way of presentation also. Everything is independent on each other, and but all are focused on the same kind of business. Now you wanted to scale your business. See, the number of customers has been increasing. Then the POS system you wanted to increase, then you can increase uh, on the need basis. And at the same time, the items updation also need to be updated on timely basis. Then you can increase the without having any dependency on the POS. The product services can be updated on their own. And inventory service also, they will do their own task. Such a way you can divide your business. So with this particular real time understanding, now we'll see what are microservices. So in this part, I'm going to cover uh, what are the microservices and what is monolithic architecture and its drawbacks, why to use microservice architecture and challenges in microservice implementation and how to resolve it, and also the tools technologies for the microservices and sample microservice architecture. Microservices. Microservices or a microservice architecture is a software development approach where a large application is composed of small, independent, and loosely coupled services. Here, small I am mentioning, small in the sense each service is a small service and that is independent on other services. So it is not depending on any other services and it is loosely coupled with other services so that that particular service can do its own task and it will serve the customers effectively. Each service is designed to perform a specific business function. See, in our example also, the POS service has designed for doing a specific business function for billing the customers. And this particular service can be developed and deployed independently without having any dependency on other microservices. And these services also needs to be communicate with each other through well-defined APIs. This architectural style aims to improve scalability, flexibility, and maintainability. This scalability, flexibility, maintainability we can achieve through microservices. The scalability means that once a particular service having the more traffic of users, then you can scale independently without affecting other services. And flexibility, you have the freedom of choosing the technology and you have the freedom of deployment of independent deployment and these particular services you can maintain independently with other services. The maintainability also becomes very easier because it's a small services. So these particular services or different services you have, but all the services can be simultaneously you can update without having any impact on other services. Now, try to understand what is monolithic architecture. The monolithic architecture is a traditional software design model where an application is developed as a single indivisible unit. In this model, all the components of the application are interconnected and interdependent. See, in this particular monolithic architecture, you have the only one unit, and that particular unit you are not in a position to divide because only one unit is there, and that is has to be taken care about all the things, all the functionalities, whatever you develop in your application, and this is these all modules are interconnected inside your single code base and they are interdependent also. One module is having the dependency on other modules and the shared variables also there. Such kind of situation. Let's start with a simple e-commerce app. Here in your e-commerce application, you have the authentication, products, users, cart, and payments modules are there. And all these modules you are developed as a single code base. And this single code base you are trying to deploy using a one deployment. And to deploy this particular file onto your deployment environment, under the production environment, you are going with a monolithic architecture. In this particular monolithic architecture, you will be having single unit of user interface and single unit of business layer and business data interface and also a single database is there. And all these things are a single unit, and if you want to scale the entire system you have to scale. If you want to deploy, the entire system you have to deploy. So this will make disturbance to the actual end user, because the frequent updates, they also notify that something is happening in the system. Now let's try to understand the characteristics of monolithic architecture. It's a single code based and it's a unified deployment. It's tight coupling, and then you have the shared databases. Let's dig into the deep. What is single code base? In single code base, you are having the all your modules or having the single code base. If you want to do any changes, you need to have the complete code onto the local environment. Then only this is possible. And then you have the unified deployment. You have the complete code in your local environment. If you are trying to change a single line also, you need to deploy entire application. And that will disturb the end users also. And there is a tight coupling. If you are trying to change a single line in one module, that may have the impact on another modules also, because all these modules are interdependent. And assume there are some shared resources also there among these modules, because it's a single code based. Then you have the single database to handle all the modules, and whatever the changes you are doing into the database or into the your application or whatever it may be, it has to use the shared database resources only. Now we will try to understand microservices. In microservices, you will be having your own microservice. That particular microservice is having its own UI, its own database. And each microservice can communicate with other microservices, or the microservice may communicate with its own database, and that microservice can communicate with its own. So there is a communication mechanism is there, but each one is a small service. Now try to understand microservices characteristics. Easy of understanding and maintenance, independently deployable, scalability, flexibility in technology, resilience, and fault isolation. Let's dig into the ease of understanding and maintenance. You have a small code base, and small focused code bases are generally easier to understand and maintain, and that can evolve over the time compared to the large monolithic application. You are having the authentication module as a single code base and users modules as a single code base. If you want to do any changes in the users module, you can easily change and you can easily understand that, because it's a small code. You can walk through the code very easily and you can easily fix, or you can improve the feature whatever it is needed. Independently deployable. So each module is independent and it's having its own code base. Then the service can be deployed and that service can be updated and scaled independently, facilitating the continuous delivery and the continuous deployment. Each service is not having any dependency on other services. There is no problem. Each one will go into the deploy production environment without disturbing others. Scalability. Each microservices can be scaled independently based on its own demand, improving the overall system efficiency and scalability. In this scenario, you have the different modules, and out of all these modules, assume there is a product module is only having the more number of users, and your cart module is having very less number of users. You can increase the resources for the product module or product service, and you can have the less number of resources allocation for the your cart module. Such a way you can scale independently on the demand for the service. And then flexibility in technology. You are having the each particular service is independent and its own code base is running, then you have the freedom of choosing your own technologies. Assume you are trying to develop a users module using Angular, then you have the freedom of development, and then no need, like the product module also you need to use the Angular only. So because you have the freedom, because it's a different code base, then you can use other tools, React, like you can use for that. And analytics module is there. For the analytics, I'm assuming like a Python is the best one, then I can use, because these three are independent code bases, and also they are running independently, but the communication mechanism is there that need to be. Then resilience and fault isolation. The failure of one microservice may not affect the entire application, because other microservices are running smoothly, they can take care. And then if the entire that particular microservice is failed, and that may not give any impact on others, and other services they will run smoothly, and meanwhile this particular microservice also having the its own uptime, then immediately it may recover from that state. You have the, because all the services are independent, there is no problem at all if any service is going down. With other services, users may get engaged. The challenges of microservices. The challenges of the microservices, the first one is the complexity in the management. Managing a large number of microservices can be complex, require sophisticated orchestration and monitoring tools, and need inter-service communication. Each service need to be communicate efficiently with which can introduce latency and potential failure points also that need to be taken care. And deployment and orchestration, deploying and managing numerous microservices are there, that is very complex. So required a containerization orchestration tools like Kubernetes or ECS, such kind of orchestration you need to. There are some best practices for the microservice architecture. The first one is automation is needed. The proper CI/CD pipeline will help us to maintain microservices, and comprehensive monitoring. Each you need to have the centralized logging mechanism so that you can maintain the healthy status of your service, the health status of main you need to monitor, and then you need to run your services independently. And single responsibility, as you are divided your business into the multiple services, and each service should have its own responsibility so that your microservices will behave good. The tools and technologies used for the microservices, for the containerization, you can use the Docker, and through Docker you can generate images, and then you can push. So that in this particular scenario, what happens? Whatever the image copy you created in the local environment, the same copy will be there in the production environment also. So that there will be no dependency changes between your development and deployment environment. Such a way, you need to have a proper building mechanism, and you need to have this proper orchestration like ECS, Kubernetes, so that this orchestration, whatever you created, that automation also needed. Based upon this particular automation, your microservices will be deployed easily onto the production environments. And also, you need a proper communication between your microservices. The way of communicating between the microservices maybe through proper protocols, and with that you need a proper messaging thing between the microservice communication, so that these services will be effectively communicated, like you can use like Kafka, BullMQ for the messaging services. Then this is the a simple microservice architecture. In this architecture, let's try to understand the scenario from the developer point of view. As a developer, you developed a code, then you are given the code commit, and that is building a code, and that is generated one image, and that image is you are trying to push into the Amazon ECR, like where the all your images are stored. And in this particular registry, from this registry, you want to deploy the things onto your cluster wherever you created, and this cluster is located in your VPC. And in the VPC, you are trying to deploy the services to your cloud formation with using one of IAM role. And then this this deployment is going through uh, one ECS task, the task definition whatever you created. And with this particular task definition, either you are going to deploy into the Fargate, means such as serverless environment, or EC2 instances. So where whatever the definition you are given, based upon that it will be deployed as a ECS service. And this particular ECS service, the service whatever you created, that is going to serve to the end users using any application load balancer. Your application load balancer will balance your load based upon the number of requests. It will increase the number of services needed for you, and also it will decrease the number of services. For, um, it will optimize the cost for you. So this is the way you can create your own microservice architecture. This is a simple architecture which I'm proposing. Then you may have, based upon your business requirement, you will be having a different microservices architecture. Thank you.